to Founder as usual for making us part of this. So today I'll talk a little bit about 3Delight and SI. 3Delight and SI is a renderer built on top of our new rendering technology called NSI, the Nodal Scene Interface. This technology allows us to do very interesting things in rendering. For example, always live rendering, multi-camera rendering, and cloud rendering. Okay. So I would like to start by explaining what we've been doing for the past year. And as you might know, one of the most important part of a renderer, a most important aspect, or probably the most important aspect, is the rendering speed. We're always optimizing the render engine. And what's more important than the actual rendering speed is probably the speed at which you get to the first pixel, because that's what defines the rhythm of your work and things like that, your efficiency at work. So we're about 3 times faster to get to the first pixel than before. And in 3Delight for Katana, we're even faster thanks to some collaboration with their performance team. We have very fast volumes now. We used to have not covered that very well, but right now we have probably the fastest volume rendering in the industry. Okay, and I have an example image here. This 4K render took about less than 15 minutes to render on a 24-core machine, and it's about 3 to 4 gigabytes of data. So it's able to load the DVDB and render it very fast. Also, we have new features. For example, a new random walk SSS, prelit materials, and tune. The tune part will allow you to do things like this, for example, this kind of looks. And we've always had a nice tune and ink shading in 3Delight, and we're continuing to develop it in our new 3Delight and SI technology. Sorry about that. This is the prelit materials. A prelit material is basically like a shadow catcher. You all use shadow catcher to integrate VFX elements into real footage. And the prelit elements allow you to, for example, this is some real footage here, allows you to integrate those CG objects inside, and gives you also this kind of AOV that contains the shadowing part, but also the global illumination part of the integration. So you can, in comp, then integrate your objects very nicely. What's new? So for the 3Delight and SI, we have also much more plugins now as we used to have. We have now Cinema 4D. We have a well-advanced Houdini integration. We have also probably the best integration for the Hydra render delegate, which allows you to use 3Delight in, for example, USD view. Okay, and we have also, thanks to the delegate, integrating 3Delight and SI into the new side effects product called Solaris. And importantly, all those plugins are now open source. Okay, so you can customize them if you want. You can explore them. It's very high quality code. It's commented and tested. It doesn't mean that they're not packaged anymore with 3Delight. The package contains pre-built plugins for all platforms. Another thing we worked on is a way to write shaders more efficiently across all platforms and all 3D apps. Okay, so you can write now a shader one time and include some metadata inside it, and 3Delight and all the plugins will create the UIs for you. Not only the UIs, but create the nodes and everything that you need. So you don't need to do C++, Python, or God forbid, Mel. You just write one OSL. And you go. So here's an example of our principal shader, one OSL. You have Katana on one side and Maya on another side. It also does it in Houdini and Cinema 4D. And we also worked a lot on 3Delight cloud improvements. So We improved the stability, the speed, and the efficiency of it. It's now used on a daily basis. We also made it about twice cheaper. And how did we make it twice cheaper? Is basically by optimizing 3Delight and also by optimizing the infrastructure that runs all that system. So for example, for a large asset like Moana, we went from about $2 to $1 here for a 4K render. And 3Delight Cloud now works in mostly all plugins: Katana, Maya, Cinema 4D, and Houdini. And I wanted to show you some timings here for some renders that our clients did. 1K, 2K, and 4K renders. As you can see, it goes pretty high with 4K renders. And this image in particular has volumes inside it. That's why it's pretty slow to render. But as you can see on the cloud, we have constant render time. That's one thing that we introduced last year. It's constant render time. We vary the amount of cores necessary to render this image in about the same time. Okay? So it's about 1.5 minutes. Same for this image. Also some volume scattering there. And we are below 2 minutes for the cloud render compared to very high numbers here for the 24-core server. And this scene also, the Moana scene, it's a particular scene, this one, because it takes a lot of resources, about 80 gigabytes of data. And we have to sync them, and we have to render them on the cloud. And as you can see, the numbers are very good. And actually, I will do a live render right now to show you how that goes. So you can render the scene in many ways, but I chose to render it from the command line using render.dl. It's our command line tool. So I hope you like the colors and the font size. So usually we'll be rendering like this, but since we render on the cloud, we'll be launching the render locally, but it will render on the cloud. We do this, and I will try to time it and see what happens. Okay? So right now it will be uploading the scene, and don't worry, we won't be waiting 20 days because there's 80 gigabytes of data, and the network is very bad here. I already actually rendered it, so the system knows that we don't have to upload much. Still, it went to 80 gigabytes of data right now when it started rendering it. And if we go to 3Delight display, we have already a frame appearing here, okay? And what is happening now? Well, now the machines on the cloud are gathering all those 80 gigabytes of data, trying to make sense of them and make an image, okay? And if we go to here in our little it's called the 3Delight Cloud Dashboard, I think. It shows you that it is parsing. And it shows you that we're using about 900 cores on this image. Okay? And this particular image, it takes some time to parse, okay? Because there is a lot of data. But usually, in your case, in your scenes, all this parsing will be almost instantaneous. So I'm really showing here the worst case scenario. And here you go. I think the pixels are trying to come through this network. And OK, I have here a 2K HD res render. And to make it a bit more spicy, I'm actually rendering 2 viewports at the same time. OK? So 3Delight Cloud can render, 3Delight can render many cameras at the same time, right? So here you go. This extremely complex scene, I think we'll be able to render it under 2 minutes from start to finish without doing anything special. And you can actually do it from home because you can download 3Delight. And we have a project, an open source project that converts the NSI data, the Moana data into an NSI file. And you can try to render it. So here it is. And if we go back to our time here, so this is the time it took from my render.dl until the end of the Moana asset render. Okay? High quality, 2K renders, 2 cameras, less than 2 minutes. Okay? Last year, we told you that we're entering a new era of rendering performance, and this is one kind of demonstration that shows that. So it's all nice, and but there's, of course, something to be said about the cloud adoption and the price anxiety. So it is difficult for studios to fully commit to this. That's our observation, okay? It's difficult for studios to fully commit to this technology because of the final price anxiety. How many tests and interactive renders will the users do, okay? And how much it will cost. If we go back to my previous slides here, for example, this 2K renders would cost you less than $1 because let's say this one is about 60 minutes. 60 minutes multiplied by 0.02 cents per minute, which is our price, gives you $1.20 for that image. Okay. So they're all about $1 for those frames, and for this one is also about $1 for those 2 frames. So it's not that much. Okay. Now to overcome this price anxiety, of course, there's a learning curve, and you'll have to basically try to render with it and see how it fits in your pipeline. But I want to add one thing, is that I just rendered it in 2 minutes, but if I waited 1 hour for it to render, and knowing how much my salary is, I think I saved some money there. So basically, it can be a gain. And for interactive renders, some no-brainer use cases have emerged. For example, our clients render posters. If they have a poster to render which is like 64K by 64K square, they want to have it in 5 minutes. They will pay whatever, $2, $3, and they'll have the poster, and it's done in less than 5 minutes for sure. So for animation and batch renders, well, when you're faced with a deadline, there is no such anxiety because the need is known and the final cost will be calculated. You know how many frames you need, and you know approximately how much a frame will cost, and you can budget it easily. So yeah, that's what we want to say about this price anxiety and the adoption. And for example, here I pulled my account today, and if you register an account, you'll have the same dashboard as this one. I computed how many dollars I spent this year, and I'm rendering like crazy, right? Because I'm developing this technology, so there's a lot of cloud renders. So I spent $3,400 because I used about 170K minutes of renders. So I think that's it. Thank you very much.